In this lesson, we're going to look at how to simplify radical expressions. So let's take a look at these three examples. Our first example, we are going to simplify the cube root of 54x to the fifth. The first thing we're going to work with is we're going to work with our number, and we are going to go ahead and create a factor tree. We know that 54 is 6 times 9, and we know that 6 factors into 2 times 3, and 9 factors into 3 times 3. Our index here tells us that we're looking for a group of 3. We have one group of 3 right here, so we can pull one of those 3's out, but we have this 2 that's remaining. So this 2 is going to stay under our radical sign. The next thing we're going to look at is our variables. So we have 5 x's here. How many groups of 3 do we have in 5? So I'm going to show you a little shortcut in this video. We're going to take the exponent from our variable on the inside of our radical and divide it by our index. When we divide it, we have 3 goes into 5 one time, and we're going to go back to 4th grade math and put a remainder of 2. And this tells us how many x's we're going to pull out to the outside, and this is how many x's need to stay on the inside. So we're going to pull 1 x out, because we know if we had 5 x's, we have a whole group of 3, and we have 2 x's that are going to remain on the inside. So we can use a division to figure that out, especially if we have large numbers. That really helps. From our last lesson, we learned that if we're taking a cube root, we only get one answer and we don't need to use absolute values, so this is the answer. We are now done with this problem. So now let's take a look at this problem here. We have the cube root of 128x to the 7th. I know that the cube root of 128 factors into, let's see, it's going to be 16 times 8. And I know that 16 is 4 times 4, and that 8 is 4 times 2. I'm looking for groups of 3 since it's a cube root. So I have a group of 3 4's right here. I know I can pull one of those 4's out, but I have this remaining number that has to stay under my cube root because I can't simplify it any further. So I write the 2 under my cube root. Now I have this exponent of 7. I'm going to do my math over here and see what I get. 3 goes into 7 2 times, and we have a remainder of 1. So I can pull out 2 of those x's. So I have an x squared, and one of those x's has to stay on the inside of my radical. Okay, this is a cube root, so I only have one answer. I don't have to worry about absolute value signs, and I'm done. My next example is we are now going to take a look at a 4th root. And so let's deal with our number first. I know that 64 factors into 8 times 8. And I know that my 8's factor into 2 times 2 times 2. And 2 times 2 times 2. And I'm looking for a group of 4, so let's go ahead and circle 4 of these 2's. I can pull one of those 2's out because I have a complete group of 4 2's. But now let's take a look at what has to stay under our radical. 2 of those 2's have to stay under, so 2 times 2 is 4. 4 stays under. So let's take a look at our variables now. If I take 3 and divide it by 4, 4 does not go into 3. It goes into 3 0 times with a remainder of 3. So I cannot pull any of them out, and 3 of them have to stay on the inside. So my x's all stay on the inside. But how about with my 6? If I divide 6 by 4, 4 goes into 6 one time, and it has a remainder of 2. I can pull one of my y's out, and the other 2 have to stay on the inside of my radical. Here's where we have an even root, and so we have to make sure that since it's asking us for the principal square root, which is the positive one, we're going to put absolute values around the items that we've taken out of our radical. But let's really simplify the absolute value part. This is already a positive 2, so I can pull that out. But since our y has an odd exponent, it has to stay within the absolute values. We're going to write our radical the way it was above, and we are done. This is our answer. And that's how you simplify radical expressions.